Well, here you may see the example that we considered on previous lecture, how to find the sum of the sequence 1 plus 1 over 2 plus 1 over 3 plus 1 over 4. And we know that this sum can be large in spite of the every term of this series is smaller, smaller, and smaller. And for example, if I run this program for x equals to 10, so we output the value of I such that this sum is greater than 10. The number of terms is 12 thousandths. For 11, number of terms is 33 thousandths. 15, more than 1 million. More than 1 million terms of this sum. We should summarize to exceed 15. 16. 4 millions. Approximately 5 millions terms, and so on. So the number of terms increased dramatically when we increase the x, because again, any term is smaller, smaller, and smaller. And if I put here 20, this sum, this loop, in theory is bounded with some number of repetitions, but really it will be endless. And the question is how I can interrupt this loop. Of course, I can interrupt it if I write here some additional condition. For example, sum smaller than x and I smaller than, for example, 1 million. In this case, this loop will be finished when I will be 1 million. And this is the value of the sum. But this condition, the loop termination condition, I can place also inside the loop with the use of special keyword break. If I smaller than 1 million, then break. We already used this keyword in statement switch to interrupt one of the branches of switch. And the meaning of break here is more or less the same. Break interrupts the loops. Break terminates the loop. And from this point of view, this condition can be considered as one more loop termination condition. If you write here break. Or, of course, this condition should be written as I greater than 1 million. When I write it as I smaller than 1 million, 1 smaller than 1 million, and the loop is finished from the very beginning. Of course, this condition should be written as I greater than 1 million. And in this case, this loop will be terminated when I exceeds 1 million. Well, again, break terminates loop. It means if I write break without any condition, the loop will be immediately terminated. Line 23 here will be end of the loop.
Do you have to put the break before the computation?
I can put it in any line, any place, before, after. From the point of view of compiler, this program will be correct. I can run it, I can compile it. Build solution, and this program is correct. But if I run this program, the loop will be terminated immediately at the point 23. I can move break from this line, for example, to this. Here it means that this loop, the border of loop will be, these two lines will be executed just one time. After that, in line 25, it's the break is written and the loop will be terminated. And of course, this keyword break usually is used inside some if statement, if inside loop. And using break, you can write several termination conditions at different places, different parts of loop body. Okay. Any questions about break?
No, sir.
Break is used rather often. And there is one more keyword. One more keyword. Continue. Continue. Let me rewrite this loop as a while, like this. The result will be the same, but it's better to explain the keyword continue for when this loop is written as a while do. And well, the keyword continue terminates the current iteration of the loop and transfers the control to the loop condition. So the break terminates the loop totally. And after the break, this line will be executed. But continue terminates the current iteration of loop. And the next line will be this, the loop condition. If I write the term, if I write the word continue at the end of the loop, it means nothing. In this case, continue does nothing because continue terminates the current iteration, but this iteration will be terminated here. And the result will be exactly the same. But could you guess what happens if I write continue at the beginning of the loop?
Infinite? Because it terminates it and it keeps going back to the condition over and over and over.
Right. Continue terminates the current iteration. And from this line, from the line 24, we will go back to the line 22. And these lines will be skipped. In this case, the loop will be endless. Well, I can repeat again that usually continue is used inside some additional condition. Well, this is some examples of the special keywords. Let me comment this part of the program. Now let's discuss about arrays. If you don't have any questions about loops, do you have any questions or not? No. Okay. Now let's discuss about arrays. And this topic, arrays, is very closely related to the topic pointers. So I have here two presentations. One presentation related with pointers, devoted to pointers, another to arrays, and I'm going to switch between these two slides, these two presentations. We will discuss about arrays and pointers this lesson, next lesson, and in the beginning of the second semester, because this topic is very large and very important. Okay, now arrays. On this diagram, you can see the data types that we use in C language. Let me remind you that all the data types can be divided into two large groups: basic types and derived types. Basic types are already defined, exists, and you can use it. Derived types should be declared and used by programmer manually. And on these two lessons, we are going to talk about arrays and pointers. Two, maybe one of the most important derived types. Usage of the scalar types only is not convenient for the representation of the data of large size, because very often we have a deal with data consisting of elements with identical characteristics, lists, tables, and so on. In this situation, the language suggests a special data type called array. So this data type, array, exists in any programming language. We can take any language, C, Java, Fortran, Pascal, Python. In any language, we can use arrays. Arrays differs in different language, but the main idea is the same. I can say that array in programming is a set of data of the same type, which have a common name and are different in location in this set and in the system of numeration. Well, when we are talking about arrays, we should say that array is a finite set of elements of the same type, and every element of the set has unique number. And the number of the element in the array is called index. Array elements occupy a contiguous area in memory and are located successively one after another. How to declare an array? For this purpose, the special operation is used on the following form. You should write type, where type is the data type of the array elements, some identifier, and some number in square brackets. ID is just an identifier, the name of the array, and num is the number of elements in the array. So the usage of square brackets in a declarative statement after identifier means that this identifier will be considered as an array with elements of this type and this number of elements, number of elements. Let's consider some example of declaration. Very simple array. Array A with number of elements 10. Array elements are numbered with integer numbers from 0 to num-1, where num is the number of elements in the array. Please remember it that the enumeration of the array elements starts with 0. And if we have 10 elements, the number of the first element is 0, and the number of the last element is 9. This style of enumeration of the elements is fixed in C language. So the array elements can be numbered only with integer numbers and only from 0 up to num-1. For example, in other languages, for example, in Pascal, we can use any integer numbers for as indexes of the elements. We should specify the range of numbers. We can specify the range of numbers. For example, from -15 up to -5. And we can use this range to enumerate the elements in the array. Even we can use for example, the letters to enumerate the elements of the array and so on. But in the C, situation is very simple. We can use only integer numbers and these numbers starts from 0. Okay, well, we have for each element of the array we have unique number index, and for getting access to array elements, in order to perform some operations with these elements, we can use this number enclosed in square brackets. Well, you see that the square brackets has different meaning according to the place where you write it. In declarative statement, square brackets means declaration of the array. In executive statement, square brackets means the access to the element of the array. Well, here I declare the element, the array of 10 elements, and with index 0, I get the access to the first element of this array. And I can use this element in any operations. If I run this program, I see on the screen 1. Okay, but suppose that I don't assign any value for this element. What I see on the screen now?
Be empty, right?
Sorry.
Empty? Nothing. It says A. It will say A0 equals and then blank.
Black? No. No. Please remember it, that the situation for any variables are the same. If I don't assign a value to a variable, here for ordinary variable or for some cell of the array, this value is considered to be undefined. And we see on the screen some undefined random number. Some very, very strange number we see on the screen. If I assign a value, I see this value. Okay, let's try to output to the screen the value with index 1. Again, in this array has 10 elements, but I assigned only the first value. The 9 other values are not defined. And I see on the screen the same random number. Well, okay, let's come back to the presentation. And one more example. It's written here. This example is written here on this slide, but I think it's better to show you this example in Visual Studio. well, some message, no. And memory location. It's when we try to output, I answer this question. When we try to output the value that is not assigned, we will see some unpredictable result. Okay, suppose that, let me declare a very short array and let me assign all the values of this array. So the array has 3 elements and let's assign it as 1, 2, 3. So in this case we see 2. If I try to output to the screen the value with index 2, we see 3. What happens? Could you guess what happens if I try to output to the screen the value with index 3?
Error, because this is outside the bounds.
Error.
Yeah.
But
error.
what type of error? Outside of the bounds.
Yes, it's outside of the.
Yeah, right. The index number 3 is outside of the bounds, but this it will be not error from the point of view of compiler. Very strange situation. You see that this array has just 3 elements, and the index of these elements are 0, 1, 2. But if I compile this program, compiler outputs succeeded, and compiler doesn't check the bounds of the array. It should be checked by programmer manually.
So it will be a unpredictable, undefined number again.
Yes, right. It will be undefined number, unpredictable number. Of course, in here, maybe Visual Studio, it's underlined this this line with green, but it's not an error. Compiler doesn't check the bounds, and this situation becomes the source of many errors. And if I run this program, I see this number. I can put here any integer number, for example, 10. 10 is completely outside the bounds. We have only 3 elements, but I can write here A10. Compiler tells us, okay, I can run this program, but we see, yeah, you see unpredictable result. Even you can write here negative number. And also compiler tells you, okay, I can run this program. Pay your attention again that compiler doesn't check the bounds. The bounds of the array should be checked by programmer manually. So A10 or of course A-1. You see unpredictable result. You can put here -10 or something like this, and you see another number. You see another number. Right. You should write You should write conditions. You should write correct conditions to avoid these mistakes. Arrays are a very powerful tool, but you should use it very carefully to avoid such mistakes. This mistake that index is outside of the bounds is one of the mistakes that is very hard to find because again, compiler doesn't check the bounds. Any questions about it?
No, sir.
Okay, I think you understand the importance of the correct conditions. Correct conditions to check the index of the elements of the array. Oops, it's about pointers. Yes, here is just the same example that you can use. You can use array. You can use array of different types. You can declare arrays of different sizes. You can use the cells of the arrays inside some computational statements, but you can you should check their bounds manually. For example, I can say that A2 equals to A0 plus A1. Just as example, how I can use their cells of the array in computational statement. A few words about initialization. Like ordinary variables, the arrays can be initialized. How we assign initial value for ordinary variable? Just assign it in declarative statements, in statement. And more or less the same can be done for array. You can write the list of initial values inside figure brackets, separated with comma. And these values will be used as initial values for corresponding array. On this example, I declare the array days that contains the number of days in months of the year, and I assign initial values 31, 28, 31, 30, 31, 30, and so on. Let me copy this example from presentation to the Visual Studio. Yeah. Here it's correct example, and the array days now contains their same values, these values. Days 2, days 2. This value will be 31. Some features of initialization. Some features of initialization. Suppose I write less number less initial value than the size of the array. The size of the array is 12, but I write only 6 initial values. What happens in this case? It's not error.
Does it fills the rest of the elements with 0?
Right. In this case, the first elements will be these 31, 28, 31, and so on, but the rest elements will be zeros. If I write here days 10, I see 0. Well, in this case, when you assign some value, these values, the skipped values, are assigned with zeros. This is one of the features. Let me delete this example. The second feature. The size of the array can be only a constant. Here I write this constant as unnamed constant, 12. But I can declare, first of all, I can write it as a constant expression. For example, 6 plus 6 equals to 12, and the result will be the same. Also, I can write here a constant, named constant, but I should declare it before. Const int size equals to 12. Or I can write here a constant expression that contains both named and unnamed constants. Size plus 1. It will be correct. In some, maybe some compilers supports the arrays of variable size, but if you use Visual Studio, Visual Studio supports only arrays of the fixed size, arrays of the constant size. Okay. The next feature. If I use a list of initial values in declarative statement, I can skip the size in square brackets. In this case, compiler computes the number of elements here, 6 elements, and declares the size, use the size of the array as 6 automatically. So in this case, the size of the array days will be 6 in this case. And if I run this program, first of all, let's compile it. We see that it succeeded, but days 10 now will be outside of the range. And as usual, we see unpredictable result because the index 10 is outside of the range. What is the largest index in this case?
5.
5, right. 6 elements. The numbers are from 0 to 5, and the largest index is 5. This situation is used when you declare the strings as an array of symbols. Of course, when you declare the arrays of numbers, you can compute the number of elements and write here the correct number. Well, the next feature, suppose that you write here 5. In this case, compiler outputs you a mistake that the number of elements in the initialization list is very large, is larger than the size of the array. Too many initializers. The size of the array is 5, but you try to assign 6 elements to these 5 cells. In this case, compiler can change the size, can change the range of the elements. Well, and of course, usually we create the elements using the size that is declared as a named constant. Why? Because it simplifies the work with array. When we declare the size of the array as a named constant, we can use it in conditions, in loop termination condition, for example. Let's output the elements of the array days to the screen. How we can write it?
For I equals int I equals 0.
Right. We can use loop for. Loop for is the most convenient type of loops to work with arrays because we know exactly how many repetitions we should perform, to perform some action with each element of the array. For I equals 0, I smaller than size, I plus plus. And cout space with index I. Let's output a space. And we see the values of this array. The first cells will be initialized by the values from the list of initialization, and the rest of the elements will be zeros. Yes, sir. If it's a question, yes, sir. All of the arrays starts with 0. The index 0 is the index of the first element for any array. In this case, I can delete all the elements, and we see 31 as the first element, and all elements are 0. By the way, this is a simple way how to initialize your array with zeros. Just declare and assign 1, 0. In this case, all the elements will be zeros. But let's 30, then 31, then 31 again, and 30, 31, 30, 31. This is the last. Yes. Yes, this is the last. Okay, the number of days. Well, let's come back to the presentation. Okay, arrays. Well, and now let me switch for a minute for another presentation. The presentation that devoted to pointers. We will not consider all the presentation, just the first slide. Let me remind you that any information object, any variable, any constant that we declare in the program is stored in computer memory. And this value occupies some cells of their computer memory. And the number of cells, I mean the number of bytes, are different for different data types. And if you don't remember the number of bytes that required to store the variable of the specific type, you can use a special operation sizeof, that returns the number of bytes required to store in computer memory a variable or a data type. Sizeof returns the number of bytes. Sizeof for example, size. Size of size. I mean this size, the constant. To avoid this, let me declare the variable j, size of j. Using sizeof, you can find the size of the number of bytes required for storing the variable. In this example, the variable j. We see that the size of j, the number of bytes, is 4. I can write here not only the identifier of the variable, but the identifier of the type, size of int, for any integer number, for any integer variable. Size of int is 4. And using size of, I can check the size of any data type. For example, float. Size of float is 4. Size of double. Size of double is 8, twice more than size of float. And the last data type that I want to show you, size of char. Char is the smallest type, and the size of char, sorry, size of char is 1. But what we see on the screen, that if I try to use not the identifier of the variable, but identifier of the array in the operation size of days. Could you guess what number we see on the screen as size of days?
16, so 12 plus 4, because they have 12 elements in the days.
No, not 16 is wrong.
I don't know. I can't guess that.
Any other ideas from other students? 48, right. 48 is the correct answer. Why? What is the type of the element in this array? Int.
Int, yeah.
How many elements are there? 12.
12, yeah.
12 elements, and each of them requires 4 bytes because, because size of int is 4. Size of int is 4. We have 12 elements, 12 cells, each of them 4 bytes, and totally we have 48 bytes.
Okay. But this is only useful for programmer use, right? Like, it's not something we can really use to write programs. The size of.
You can use it. You can use it, and in some cases, it's a very useful operation. Maybe later I will show you some examples where you can use it. Okay. And by the way, I can show this example right now. Suppose that you declare an array, and suppose you declare an array like this, without declaration of the size of the array. How to find the size? How to find the size of the array? To find the number of elements.
And then divide by 4, so. Right?
Size of days over size of int. size of days over size of int, and you can compute the number of elements.
Okay, okay.
This is one of the examples where you can use sizeof. It's just an example. Just an example. And well, maybe let's discuss about pointers. Let's start to discuss about the pointers right now, or maybe I don't know, maybe next lesson we start to discuss about the pointers. Now I want to show you some examples with arrays. Here, consider some examples from practice already, but maybe my examples will be the same examples from another point of view, because we consider some features of using the arrays. I think you understand how to use sizeof. Suppose that we have this array, and suppose that the size of the array is large. 1,000. Of course, in this case, we cannot write the initial values for this array in brackets. It's impossible to write 1,000 values. In this case, it's better to assign the values in the loop. This loop assigned values from 1 to 1,000 to the array days. Now, of course, it's not a days. It's better to declare it as just D, size of D. And after that, let's output these values to the screen. I assign all of the values and the values from 0 to 999. And I output these values to the screen. Yeah. You see that in this case, again, the operation sizeof returns us the size of the array. In this case, the size of the array is 4,000, and you can compute the number of elements here. After assignment, the size 100, not 1,000. After assignment, you can perform some actions with the array. For example, let's consider the case. When I want to assign to the arrays to the array. So the array elements, so-called Fibonacci numbers. Do you know what numbers are called Fibonacci numbers? Do you know such numbers or not?
Yes. Yeah, it's the ones that like they add up to each other, the previous number.
Yeah. Fibonacci numbers. Fibonacci numbers. The number I equals to previous number plus the number with index I minus 2. Let's do it. Di equals to di minus 1 plus di minus 2. What's wrong in my program? What's wrong in this loop?
You didn't see out.
See out?
Oh no, you did. Okay.
I mean here in this assignment. What is wrong?
You have two for loops. The first for loop, when you assign di to.
Okay, I just assigned. Well, the first loop is for assignment, and in the second loop, I want to change the values of this error. From this point of view, it's okay.
Oh, your condition. You started from 0, but you should start from because if it tries, yeah.
Right. Yes. Please, I explain it for other students. The loop condition is wrong now. I start the loop counter from 0. I equals to 0. If I equals to 0, this element will be d minus 1, and this element will be d minus 2. So it will be a mistake that the index of the array is outside of the range. And this is one of the mistakes that compiler doesn't check. The program is succeeded, and if you try to run it, you see some unpredictable numbers here. What index I should use here?
The 2.
Index 2.
Yes.
Because for index 2, this number will be 0, this number will be 1, and this I will be 2. And the program is correct now. And if I run this program, or the number becomes very large, but it's also a good example. Let's size equals to 10. In this case, yeah, you see that the number, each number equals to the sum of two previous numbers. This number equals to 5 plus 8. This number equals to 8 plus 13. This number equals to 13 plus 21, and so on. For example, let's assign 20. Also, yeah, you see that all of these numbers organized in the same way. The number I equals to the sum of the numbers with indexes I minus 1 and I minus 2. But what happens if I put here 100? Why we see here run Why we see here negative numbers?
It passes the 2 billion.
Right. We have the situation of overflow because this number becomes greater than 2 billion. Somewhere, I think, somewhere here, this situation happens. And after that, we have negative number. So we cannot compute 100 of Fibonacci numbers using type int. Maybe we can compute. Yeah, right, 30, 50, even I think 50 numbers. I think 50 numbers. No, when you try to compute this number, it exceeds the range. Well, it's just an example how to work with arrays. I think that you consider a lot of examples on practice too. Well, do you have any questions about arrays?
Also.
This is the last lesson this year, the last lecture, and the next lecture will be January 10. We will meet after holidays, and we start to discuss about pointers after the holidays. Now let me stop recording.